Uh-oh. All right, he's coming. He's coming. I gotta grab this sword over here. Okay, and then let's see here. Let's get in position. And we'll do. All right, there we go. Let's attack. Oh, he's attacking me back. Let's see. Let's come in here and we'll do almost there. He like, how long does it take? Okay, there we go. In this video, we're gonna implement a very basic combat system. This will be the start of our combat system. Obviously, you probably saw that there wasn't animations yet or, some other features. So yeah, let's get started. The code for this video, as well as all other videos, are on GitHub. The link is in the description below. In addition, all of the assets that you find in this game are on my website, and you can download them and use them for this game or other games as well. I have VS Code open. Let's go ahead and go into Source, Components, and we're going to create a new file called combat.py. Anything that can go into combat is going to have a combat component. The combat component is going to look something like this. So we've got the health and the max health. Which is how much health the thing has. The global cooldown, which is when you use a weapon or you use an attack of some sort, there's going to be a cooldown of how long it takes. So something like a dagger might have like a really short cooldown, so you can like attack again really quickly. A sword might have a longer cooldown, etc. The current equipped weapon is going to be here. It's going to be set to none initially, so we don't have any weapon that's equipped. Similarly too, we have a weapon sprite here, which is the actual sort of sprite that you're holding. We have a regen amount on the health, and then also we're taking in a function that basically this combat component's not going to be responsible for what happens on death. So we're going to take in a function of some sort that's going to be called whenever that happens. And then this is going to update every single frame, so we're going to add that to our active objects on our engine. The next method here is going to equip an item. We're going to set the item to what we want, and then also we're going to create a sprite for that too as well. So like if you're holding the sword, you'll actually see the character hold the sword. Similarly, we also have an unequip function, which does exactly the opposite. Now, I added a delete self method to entities. We'll get into that as we kind of go along a little bit. When we break down the thing too, we kind of want to do exactly the same thing. We're just going to remove ourselves from the active objects, and then we're going to delete the weapon sprite. Next, we have a function for performing an attack on another combat component of some sort. There's two checks that we need to do. One is that if we don't have any weapon currently equipped, I'm just going to assume we can't attack, but maybe you want to put some code in there for like an unarmed kind of attack, right? An attack without a weapon or something. So if that's the case, feel free to put something here. But for now, I'm just going to not put anything. And then if we're still on a cooldown from another attack, we're also going to hit return to as well. So we're not going to let the player or enemy or whatever attack if they've already done the cooldown. And actually, this will make it really nice and easy because both the enemy and the player can just like keep trying to attack. And if the cooldown isn't fit yet, then it won't let them. Next, we're going to get the damage that we're going to do. We're going to subtract the other person's health. And then we're going to set our cooldown. And yeah, we'll go from there. We don't need that. Our next part here is we're going to create the actual text for how much damage you did. In video games, you might notice that there's like, when you do some damage or something, it tells you how much damage that you did. We're going to have the same thing. We're going to have, like you saw earlier, we're going to have that. So we'll come in here and we'll do that. This function we haven't coded yet, but we will shortly. When we perform the attack, we want to check and see if the other person has ran out of health. And if that's the case, we're going to call the other on death function, and we are going to pass in the other entity to that function. Next, we have a perform attack function. And what this is going to do is this is going to attack nearby enemies. So it's a little bit different. So the attack function attacks a specific entity, like, oh, I already have identified a target. Whereas the perform attack function is just going to swing your sword. right? And maybe the sword will hit. And this is actually where we have yet another function that we're going to end up using. So there's, we have two, right? This create hit text, which we'll get to in a second, and also this get bodies within circle function. We're going to extend our physics to be able to get all of the objects within a certain circle. And this will be very useful for things like this, and also will probably come in useful later as well. Because then from there, what we can do is we can loop through each one of the nearby objects. We don't need to print it. And then we're going to come in here and we're going to perform the attack on that if it's a combat entity of some sort. We also don't want to attack ourselves, so we're just going to make sure that the one that we found is not ourselves. We do have an update function. The update function is going to check the cooldown. So if we have a cooldown that's running, we'll just subtract 1 by it. And then also 2, we're going to allow the health to regenerate too as well. And if for some reason after we regenerate the health, if it goes above the max health, we'll just set it to the max health. This will prevent the combat component from going over the max health. The very last thing that we're going to do is we're going to position the weapon sprite, so like the sword or dagger, to be in the person's hand. Now, this could actually be kind of interesting because you might have like a, I don't know, like some kind of monster or something, and maybe they don't have a weapon or something. We'll have to kind of figure that out. But either which way, it's going to position that particular weapon to the person's hand. Excellent. So this is actually the combat system in a nutshell. Obviously, it's using a couple different things like this function and also this function, which we need to implement. But this will basically do the logic of basically a combat system. So now let's go ahead and let's do our enemy class, and we'll go from there. Jump into components, and we're going to create a new file called enemy.py. I ended up importing the following in the enemy class, so go ahead and do the same as well. The enemy class is going to have 3 categories of fields. The first one is the base combat attributes. These are actually just going to be passed on to the combat component, and actually it'll be removed from the entity later. But it'll make it nice and easy for us to use these. When you create an enemy, you can just now like say, hey, here's the health of the enemy, and then this is what weapon they're using, and then you can set them here. Here are all of the AI attributes. The target's like the target location that we're going to go to. The targeted entity is going to be which entity that the enemy is attacking. Step to update. I have a bit of an optimization when it comes down to AI that will allow us to run our AI code a little bit faster, and I'll get into that here later in the video. But this step to update has something to do with that. The vision range is how wide the enemy can actually see. This will get important later. And also the walk speed is how fast the enemy can see. Sorry, I have those mixed up. How fast the enemy can walk. Then we're also going to make it so that the enemy can update. So here's something else I want to mention. We're going to actually modify our entity class a little bit to call a setup function afterwards. This will make it so that you can set up the entity or access any of the components in the entity. It's kind of like the constructor, but here in the constructor, you can't access the entity because it hasn't been set yet, and that's okay. But in here, we're going to have a function that you can do additional setup on the entity. We're going to create a combat component, and we're also going to pass in a function here. What happens when the enemy runs out of health, right? Then what we're going to do is we're going to keep a reference to that combat component, and we're also going to call equip, and we're going to equip whatever item it was, and then we're going to delete the health. We're not going to delete the weapon that we have, but we will delete the health number because we no longer need it on the enemy. The combat will be fully responsible for handling the health. We brought it in here just for convenience, so when you create an enemy, you can set the health, but we no longer need it, so we'll delete it here. So this enemy on death, or on enemy death, we need to now code that function. go up to the way top and go right before the class enemy. And we're going to add a function that calls the onEnemyDeath function. We don't need that. And basically what it's going to do is all it's going to do is just remove the entity from the world. So the enemy will just disappear. Perhaps later in another video, maybe we can do drop tables and we can do some other kinds of things that can happen too as well. But for now, let's just have the enemy disappear. Come in here and we'll do a breakdown function. So this will just break down the enemy completely and we'll go from there. We'll do our breakdown function. This will just make it so that it doesn't update anymore. Here's two methods that we're going to do. So we're going to do an update method like normal, right? It updates every frame. And then we're going to do an update AI method. And I want to show you a little trick that I use to make AI run a little bit faster. We're not going to run this function every frame. In fact, we're going to run this function probably twice a second, a lot slower. And that may seem like, well, why would you want to do that, right? Well, if you do that, you optimize the AI code 30 times, right? Because you're not running it every single frame. And the benefit of doing that is then you can kind of put some expensive code in this AI function. You can have it like search all of the entities that are around you, and you can make decisions and kind of intelligently plan out what you're going to do. And it may be somewhat expensive code, but it's only running twice a second. Furthermore, I'm going to show you a trick that we can kind of spread out when every enemy, does that update. So because of that, that basically means you can have a lot of different enemies and they're all updating their AI, but it's doing it in a very, very efficient way. We're going to do the update function first. Go ahead and bring in the game engine, and then the engine is going to have a new step variable, which we'll get into. Basically what we're doing is every 30 steps, as long as it's equal to our step to update, we're going to call the update AI function. Let me explain what's going on. So every enemy is going to have a number between 0 to 30. And basically that number determines when it's the enemy's turn to do any of its AI logic. So this enemy might be 23, right? So there's going to be 23 frames that will occur before the enemy has its turn to update the AI. And in this AI function, we're going to have the opportunity to do some expensive code, right? We can look at all the different entities and we can say, okay, is the player anywhere around here, right? And then if the player is there, let's set the target to where the player is, right? And because of that, because of that, you basically make it so that this function, again, like I said, updates 30 times faster, right? And that you can literally have a lot more enemies in your game in a single area by doing that. Let's go ahead and now code our AI. Inside of the AI function, what we're going to do is we're going to come in and we're going to get the player, and we're also going to get our function get bodies within circle that I talked about. So this will get every single one of the entities in the circle. What's really nice about this function is we can just call this function and say, hey, get me all of the objects that I see, right? It's going to say from my location, right, where I am, and then my vision range, like how far I can see. An enemy, by default, right, we come up here, it has 500 pixels that it can look at. So, right, if you're within a 500 pixel radius to the enemy, then we're going to add it to that list, and then you'll have a list of all of the seen objects. Okay, we're going to look, enemies are just going to look for the player for now. We're going to look through each one of the seen objects, and then we're going to see, hey, is this entity a player, right? Does this entity have a player component on it? And if so, we're going to set the target location of where we're going to head to the player's location. And also we're going to set the targeted entity to that entity that we found. And we're going to say that we found the player. if we get through all of the entities that we see, right? We see a tree, we see a rock over here, whatever. And if we're not able to find the player, we're going to set the target to none. And we're also going to set the targeted entity to none. So we'll just clear it out. So now in our update code, we can do relatively a little bit more inexpensive operations. We're going to check and see if we have a targeted entity. And if we do, we're going to try to attack that targeted entity. We need to get the range of the weapon that we're holding. We'll go in and we'll calculate the distance from us to the targeted entity. And then if we're within range, right, if our weapon distance is longer than the distance to that entity, we're going to come in here, we're going to perform an attack. And remember, the attack function is awesome because if we're on a cooldown or something, it'll just ignore it, right? So the enemy can easily just call this attack function every single frame, right? That's not a problem. And it'll just, hey, if we're on a cooldown, it'll just return and it won't actually perform the attack. When you're coding like AI code in a video game, you want some sort of physical constraints, right? So the attack, like the global cooldown found in the attack method is kind of like a physical constraint on the AI, right? The AI is going to want to just like attack as much as it possibly can, but you're constraining the AI to basically say like, well, you have to follow the rules of the game, right? I'm forcing you to say you have a cooldown, right? But the AI, as far as the AI is concerned, is just going to keep trying and doing that, right? By the way, a little distinction here. AI is kind of like a buzzword today, and the stuff that we're doing is not deep learning. It's not neural networks, anything like that. This is video game AI, so there is a drastic difference between those two. Anyway, we're similarly going to see if we have a target. Again, we're just checking to see if we have a target, right? If we found one in our AI method. If that's the case, we're actually going to move. The movement code is going to be really similar to the player. So we're going to basically keep track of where we previously were. We're going to move the enemy to its new location, and then we're going to validate that new location. And if it's not a good location, then we're going to roll back. We're going to move back. Yeah, we're going to come in here, we're going to perform the movement, and then we're going to validate the position. And if the position is not valid, we're just going to roll back to that previous position. Same thing here. We're going to do the same thing for the other position too as well. We are completely done with the enemy code. So let's go ahead and we'll move on from there. So I mentioned that we're going to change the entity code up a little bit. So let's jump into entity.py. What we're trying to do here is we're trying to make it so that we call a setup function if that component has a setup function. This will allow the component to set up anything on the entity and to access other components when it's first setting up. Let's go ahead and jump into this add function. By default, when we add a component to something, we're going to say perform setup equals true. If we are performing the setup, we're going to say, hey, does this component have a setup method? And is it callable? We're sort of introspecting that component. And then we're going to come in here. If that's the case, we're going to call the setup function. So this makes it so that a component can optionally have a setup method if it wants, right? Hey, like if you go into this enemy class, right? We've got a setup method, right? We're basically saying, hey, we want to add a combat component to the entity that this enemy is on. So any component now can optionally have a setup method. We are calling add here. So what we're going to do is we're going to call false. We want to add all of the components to the list first. We're going to then loop through each one of the components and then call setup on that. Okay, so next thing too, we're going to have a method called delete self. And this is basically going to take this entity and it's going to delete itself, right? This will make it a lot more convenient to remove entities from our game. What we're going to do is just to explain this real quick, we're going to remove ourselves from the area, right? From the sort of game world. And then similar to our remove component, any components that have a breakdown method, we're going to call it, right? And then we're going to clear out all of our components. We're just going to get rid of all of them and delete them. And that is all of the changes for the entity class. So how do we equip weapons? On the player is going to be able, as you probably saw earlier, the player is going to be able to click one of those slots and, in its inventory, and it'll equip it. So let's go to inventory.py. Go ahead and scroll down to your inventory class. And we're going to add one thing to this, and that's the current equipped slot, which will be none. We're not going to do anything else in this file other than that. We're going to keep track of which slot is currently equipped. So the other thing too, when we were doing our combat stuff, you might have noticed that we did our get bodies within circle function that finds all of the entities within the circle. So let's go ahead and do that code. Let's jump into physics.py. We currently have in our physical object class, we have a is colliding with, which checks to see if something is colliding with another thing. What we now need is a function, or sorry, a method that will check if a circle is currently colliding with this physical object. A circle has a center, right, in X and Y position, and then it also has a radius around it. What we're doing here is we're actually doing a rectangle to a circle collision. And I found a really good optimized kind of solution on Stack Overflow, which I'm going to link also in the description below. There's a great explanation on how this particular algorithm works. Obviously, this is adjusted for Python and for our own code a little bit. So there are some minor changes, but absolutely, credit where credit is due. What we're going to do is we're going to get where the hitbox is. And then we're also going to find the distance between the circle's center and then that hitbox. So imagine we have this entity over here and we're trying to check this circle over here. That does not look like a circle. But basically the idea is that we can actually draw a rectangle around that circle, and we can first check this to see if those two are colliding with one another. This will just be a little bit more optimized to do rectangle to rectangle collision initially. So jumping into this, we're going to check the width of it. If they're not even colliding, then we're going to return false. We're also going to check the Y position. If the rectangles are not colliding, like if the one's way up and then the other one's way down, then we're just going to return false. Same thing here too. This one right here checks if the circle is like way to the right. This one right here checks if the circle's way to the left. This one here checks if the circle is way below. And then we also have to check if the circle is way to the top. Now, at this point, the circle and the rectangle are not colliding, but the rectangles that you draw around them are, right? Just slightly, but they are within it. So now we need to do now that we've determined that they are colliding, we need to do additional checks to see if this circle is within this rectangle. And here's where you're actually going to check the distance between the circle distance and the corners. So this will actually come in here and it'll check the distance of how close it is to one of the corners of the rectangle. And then all we do is check if the radius, if it's within that. You can kind of see that the radius in itself has not made it to that rectangular corner. So it's not enough to actually be a collision. Now that we are able to check the circle collisions, let's go ahead and scroll up to the top. And all we need to do is add a function now that this function will check each one of the bodies to see whether it's inside of that circle and then return it. Next, we're going to modify the player to do combat, but before we do that, let's code a health bar. We're going to create just a bar class that if you have like stamina in your game, or if you have any other statistics like mana or something, you can also display those with this bar as well. Let's go over to UI and let's create a new file called bar.py. So this is in source, components, and UI. Our bar class is going to have an amount and a maximum. And basically what it's going to do is it's going to divide between the amount and the maximum. And that will be how much, the bar goes from either completely full all the way to empty. We're going to have a color that we're going to use. So a background color and a foreground color that we're going to use. The foreground color is going to be green. and then the background color will be red. And then we'll have a width of height of the bar, and then we're just going to add ourselves to the drawables. And this will be part of the UI, so we'll add ourselves to the UI drawables. Like I mentioned earlier, we need to figure out this ratio. So let's say that we have 100 health, and let's say that our maximum is 200. So that would be halfway full, right? So this would be 0.5, so it'd be 50% full. So yeah, we'll get that number. First, draw the background. And we're going to use something a little different that we haven't covered yet. Pygame.draw comes with a bunch of functions for drawing like basic shapes and stuff. And we can just use the rectangle one. We pass in the surface that we want to do, which is the screen. We're going to draw the background color, which is red in case of the health bar. And then this is the position that we're going to do it at. We're going to do it at our location, and then also the size of the health bar. Drawing the foreground is basically exactly the same thing, except we're going to do the foreground color. So we're going to do green. And then we're also going to, the width is going to be based on how much it's filled up. So if you have full health, then we're going to draw the entire green bar. If you have no health, you're not going to see it at all. It's just going to multiply it by 0. So it'll be, you won't see it. And then if it's halfway, you'll see that it will be half of the width, right? And that's actually it for the bar class. Next thing, we're going to modify our inventory view to select a particular item to equip. So let's go ahead and jump into inventory view. We're going to add a selected slot, and you know what I'm going to do with this is I'm going to make this a little bit cleaner here. Basically what we have is we have another image. This is available in the description below to download it. We're going to have a selected inventory slot. You click on the inventory, you click on like your sword or something like that, and it'll actually be highlighted around that sword to kind of indicate that it's selected. We're also going to keep track of that image as well. And now that the inventory view is handling user input, we're going to add ourselves to the active objects, and this will get an update function as well. So right after the constructor, right after self.render, we're going to add a update function. And what we're going to do is we're going to get the mouse position and whether it was just pressed. We're going to check to see if the left mouse button was just pressed. We're going to check to see if the mouse is inside of the inventory view. Let me put pass here real quick, and I'm going to run it real quick so I can just kind of show you what I mean. So the inventory view, let me move my head. The inventory view is over here on the top right. So we're going to check and see if the mouse is somewhere inside of here, and we'll basically check to see if the mouse is clicking on one of these. What we're going to do is we're going to check or get the exact slot that the mouse is on. So we're going to get the mouse position, right? We'll come in here and we'll do that relative to the window. And then we can get the slot by basically doing the size of the slot plus the gap size too as well for X and Y. And that'll determine which slot that we're actually, our mouse is over. This is the position inside of the slot. And this is going to be useful for determining basically the gap, like whether we're in the gap or not. And what we're going to do is we're going to check and see if these are above like 32, which is the size of the item size. And if it is, then it's inside of the gap. If you want to see all this stuff in action, you can actually just print this too as well. So like I said, we're going to check and see if the local position is actually on one of the inventory slots. If it's bigger than that, and then it's inside of the gap. And then what we'll do is we'll set the index of whatever slot was selected. We're also going to set the inventory's equipped slot to whatever was selected. And we're also going to call a self.refresh to just redraw the entire screen. I added a couple print statements here. This will be very useful for debugging purposes. When you click one of them, you should have an index be selected, and then when you click it again, it should say none. And then this will also print the slot that was selected. So last thing that we need to do is we need to actually draw this slot. So let's go ahead and go down to our render function. Here, what we're going to do is we need to know the index of the slots. So we're going to type the word enumerate in front of the self.inventory.slots, where we're actually looping through each one of the slots. And then we're going to come in here and we're going to type index in front of the slot. So now we know the index of each one of the slots. Right before we set up the container sprite, we're going to come in here and we're going to get the slot image. Make that a little bit clearer. So the slot image is going to be the selected one, right? The one with a selected border around it, if we've hit the selected inventory slot. If we haven't, then if it's just any old plain inventory slot, then we're just going to draw the regular image. Here, what we're going to do is instead of doing the slot image when we set up the container sprite, we're going to then just type slot image, and we're good to go. And that actually is, we're done with the inventory view. We've written a lot of code so far, so to test it, go ahead and press the play button. And then on the right, top right, just go ahead and click one of the inventory slots and you should see it light up. So it should then light up with whatever inventory slot was selected. And if you click one of the, like inside the gap, it shouldn't necessarily select it. So take a look at the terminal too. It also tells you which index is selected each time that you do that, if you did those print statements, which I think will be useful later on as we kind of debug this, because it's quite a bit of code. With all that in place, let's go ahead and jump into player.py. Up at the very top, we're going to import our bar class, right, for our health bar. Also, we want to do an on-death function, right, like when the player runs out of health. So if they run out of health, we're just going to switch to the play state. It's just going to reset the game. But you can obviously put anything in here that you want. By the way, we are passing an entity even though we don't need it, just because any of these like on-death functions are going to take in an entity of some sort or whatever. It's going to pass in the entity in case you need it. Let's come in here, and when we initialize the player, we're also going to ask for health as well. So this will be one of the biggest kind of changes to the player class that we've done in a little bit. Go ahead and add the health up here. And then players are also going to similarly take in health as well. We now have a setup function, which actually has been kind of sitting there in some of the code since, for quite a while. We just haven't really needed it yet. But now we do. Let's go ahead and set up our components class. If you don't have this yet, go ahead and add it. We're going to do some really similar code to what we did with the enemy. So we're going to create a combat component and we're going to add it to our entity. Because of that, this is also a great place that we can create our health bar to as well and create an entity for it as well. The colors here, take a look at this. So the first color is red. So these numbers are red, green, and blue. So we're just going to do maximum on the red, 0 on the green, yeah. And then this one right here is green. So this is the foreground color. So background color and foreground color. You can obviously put your own colors in as well. We want to put the health bar at the bottom right corner. So we're going to get the size of the entire window, and then we're just going to subtract it from the bar, the health bar width and from the height respectively. So like put it at the very bottom left corner, and then we'll kind of move it up depending on the health bar size. Now, jumping into our update function. This is where we need to, we can come in here just maybe right after the previous one, previous X, previous Y. We can update our health bar amount. So this will, even though the health can go up and down on the player, we need to let the health bar know that that happened to see any changes. So we'll come in here and we'll set the amount to that. Next, let's come down to our interact code, and we are going to have to modify it a little bit. Right before the core input, we get the mouse position and stuff. Go ahead and, right after it, we need a way to let our combat component know about a weapon that was equipped. So we'll come in here, and if we have an equipped thing from our inventory, if it's not none, and if we have nothing for the equipment, we're going to call our equip function on our combat. And this will actually make it very useful to print out equipping to as well, just as we're debugging this. We're going to likewise do the exact opposite for unequipping the thing too as well. And I'm just printing a couple things here too as well. I actually left these print statements in here. I used them when I was debugging. And while you're kind of debugging it and stuff too, if you run into any issues, this might come in handy here. We're going to modify our interact here. So let's go ahead and get rid of that. And instead what we're going to do is if we have something equipped in our combat thing, if we don't have it, then we're going to interact. Otherwise, we're just going to call perform attack. And our combat component will be completely responsible for figuring out like if it hits any enemies or anything like that. That's actually it for the player. Next, we need to draw text of the damage numbers when you actually hit something. So let's come in here into our effect.py. That's in core and effect.py. We're going to set a couple different default values for our hits. So yeah, what we're going to do is we're going to say our X speed and Y speed. We're just going to make it move up a little bit by doing -1. And then we'll have it last for a second, right, for 60. And then the size, the text size will be like 30. It won't load a font yet, but it will on the first one that it does. And then we're going to do that. This is referred to as lazy loading. So basically, you don't have it until you need it, right? So the first time that we call one of these, we'll load the font. Also, too, you may have a different font than I do. So this is in content, fonts, and I have a bunch of fonts there, but you might have different ones. So go ahead and just do the font that you have. I have a previous video too as well, which I'll put a card here for the video on fonts and how to do that. Okay, and then what we're gonna do is we'll come in here and we'll create our hit text. So again, we're gonna lazy load our font, right? If we haven't loaded it yet, we'll load it. And then what we'll do is we'll just we'll get the image of the actual text itself, and then we'll create a new effect with that particular image. And it is going to create a new image every single time for each one. But as soon as this effect is gone, then it'll just clean up that, that text. One more thing too, go up to the very top and we're going to import Pygame so that we can use it. We need to make a slight modification to our engine too as well. Jump into SRC and we're going to go to core and then we're going to go to engine.py. Our engine, up at the way top of the constructor, we're going to say self.step equals 0. This is going to be particularly useful for determining how many frames have passed since the game has been running. And this is particularly useful now for our optimization that we did earlier, but can become useful later on if you want to know how long the game has been running. All we have to do is go into our run function, and right in front of self.running, we're going to come in here and we're going to say self.step plus equals 1. So we're just going to add 1 to the step in our game loop. One quick thing I'll mention too is that the effects are actually drawing before the drawables. What we're going to do is we're going to move these effects. So I'm going to come in here, I'm going to cut it, I'm going to move it down here so that the effects draw over all of the like sprites and such on the screen. Thank you for sticking with me on this. This was actually quite a bit of code. So we actually have a lot of the code in place and all ready to go. We now need to kind of set up our actual data of our game to compensate for all this. So let's come in here, let's go into data and we'll go to item types. And inside of this, we're going to add 2 item types. So we're going to add a sword here that the player can pick up. And we're also going to add a weak sword for the enemies to carry. So while we're just testing this system, we're going to have a weaker kind of version of the sword that the enemies will have that we'll just do. But yeah, take a look at this for a second. So it's just like any other item type, but we added these KW args here. So you can have any sort of stats or whatever that you want in any sort of item type. So we're going to have a couple different stats here. We're going to have the damage that the item does. We're going to have a cooldown, which is how much time in seconds that it takes for the next attack. And then the range, which is how far away in pixels that you must be in order to perform the attack. You can obviously adjust these two as well. Maybe we'll make it so that the player can attack a little bit longer range than the enemies can. That'll make it so that, you have to kind of, as a player, you have to kind of, attack and then get away here a little bit. So, yeah, perfect. Okay, and then the other thing that we want to do is we want to go into objects.py. And inside of our objects, we're going to add a new enemy. So yeah, we have a new enemy factory here. The enemy is going to take in a health and then also the item ID of the weapon that it's going to carry. The body is actually very similar to the player, and then it's also going to take in a sprite as well to it. Also, one other thing too, go into your player class up here at the top, and we're also going to give the player health as well. The player now needs health. One other thing too, come in here and we'll import our enemy here up here at the top. One thing really quick too is if you're in objects.py, some of the previous code has had this enemy here. Go ahead and just remove that if that's the case for you. The code should largely be there. So now let's go ahead and modify our level to have enemies. So we'll go into content and we'll go to maps. And then we'll go to, for me, the first one is forest. First test that we're going to do is we're going to add a sword. So a sword, 7 is the, for me, 7 is the factory for a item ID. And then we're going to put it at 9 and 3, X and Y. And then the item ID is going to be 3, and then we're going to have one of them. Okay, so let's go ahead and test it. We'll go to main.py and we'll run it. And we'll come in here, let's pick up the sword. And I'm going to click the sword, and there we go. And the player is now holding the sword. And yep, there it is. So now the moment of truth, let's go ahead and add an enemy. So let's jump into forest map. And then we'll come in here and we'll add an enemy to this. Let's go ahead and we'll scroll down. We'll jump into main.py and we'll run it. And there we go. And we now have an enemy that's chasing after us. Cool. And then if we get close, yep, the enemy is now doing damage to us, right? There we go. And then if we swing back, we can do damage to the enemy too as well. So test a couple things. Test that you can actually defeat the enemy. So we'll come in here. Yep, there we go. And we're able to defeat the enemy. Another kind of boring test to do as well is we can unequip this. Let's see, unequip it. Okay, another test that you should do is just kind of wait for the enemy to defeat you. So I hear Jeopardy music in my head. Yeah, because he's only doing 2 damage every single time. It's going to take a little bit to get through 100. You could obviously, if you're lazy, you could increase the damage to as well of the weak sword. But yeah, let's see what happens. We're almost there. Okay, and it actually resets the game. Now, a couple things to mention too as well. Number one is that the game resets completely, and the player didn't like lose anything or whatever. Yes, they were brought back to the original area, but there's a couple things that you can kind of change about this or whatever. If you want to empty the inventory too as well, you can jump into, I'll show you where to do that. I'm going to close this and let's go into player.py and we'll scroll up to the way top. And in this onPlayerDeath function, you can obviously change this to whatever logic you want to do. So if you want to empty the inventory, like if you want to just do like inventory equals inventory, 20, you can do that. I'm not going to do that, but you can if you want. That'll just destroy everything in the inventory. Thank you so much for following along with this. This was actually quite a bit of code, and this gives us a solid foundation for implementing more combat stuff and mechanics and stuff later on. Obviously, another thing too that I'll just mention is that the combat needs a little bit more kind of mechanics that are more interesting about it. So maybe we can add something like different types of attacks, or maybe we can add different kinds of weapons, maybe equipment or whatever. In the comments, feel free to let me know what you guys would like to add to this or what you would like to see added to this game. Also, too, another thing that's really critical too as well is to add animations to the combat system. So with that being said, I hope that this video has been helpful. Thank you so much, and I hope you have a good rest of your day.